Hey guys, Whale Hater here doing Packet Tracer 9226 of the Course 3 for CCNA. This Packet Tracer is getting into our multi-area OSPF for just the version 2. And the Packet Tracer part's not so hard. It's answering the questions in this PDF that's the tough part. So let's start configuring our routers here. And one thing that was kind of confusing for me when I was going through this thing is one of these things is not like the other. You can see that the areas that they have shaded in here aren't exactly represented well. The other thing is this area here is like cutting into the area 0 cloud. If we just extended that a little bit more, it would make a lot more sense. So let's start our configurations. R1. All right, so router OSPF, and we're going to give the process ID of 1. Let's give ourselves a router ID of all ones there. Next, let's do our network commands. Network 10.1.1.0. Wildcard mask is going to be 255. Area 1. Enter. Next, let's just do an up arrow. Doggone it. Up arrow and change this to a 2. 10, 1, 2, 0, 255 is the same area 1. Yep. Let's do another one of these. Start over. Network 192.168.10.0 and 000, and then we're going to give the 3 command because it's going to be a /30 for the subnet mask. Area 0, and we're just going off of here. The other networks, though, we're going to have to go off the actual addressing table. Okay, so that one's done. Forgot to get our scorecard up and running. Alright, so we got 28 points so far. Router OSPF 1 for the process ID. Router ID is going to be all 2s as per our command right here. Network. Now let's go up to our addressing table. Our addressing table says that for the network 10.2.1.0, that will be the network ID. And then the subnet mask is going to, or it's going to be a wildcard mask. It's going to be 255s because it's inverted. Total inversion. Area. Let's see. Area is going to be 0 on these guys. Okay, the next network is a 192.168.10.1. And that is a 255, a 252. So again, we're going to invert that with the 255s, and that's going to be a number 3. Area 0. One more up arrow, and we'll just change that 5. Well, actually, we could have given it, shouldn't have done that ID like that. It's actually going to not be a 1, but a 0. That doesn't matter. I guess the adjacency still came up. And then change that one to a 4. Because the 5 is the interface address, but if in a /30, it would start at 0, then it would go to 4, then it would go to 8, then it would go to 12. So that's just how that works. Anyway, let's back up out of that. Same thing here. Router ID 333. Network. Okay, we're going to the 192.168.2.0. Looks like it's a wildcard mask. It's going to be .255 area 2. And the next one's going to be, instead of a 2.1, it'll be a 1.1. 1.0 rather. And the last one is going to be 10. That's a 6, so that'll be a 4. For network area, let's see, that'll be a 252. So again, that's a 3. Area 0. There we go. We got our full points. So everything in here is configured now. What can we do to answer some of these questions down lower? It says we've got the show IP protocols, show IP route, show IP OSPF database, and show IP OSPF interface, followed by the show IP OSPF neighbor. So which routers are internal routers? Now, going back to our thing up here, it says that an internal route, or what this is a better picture of, or depiction of what the areas are than over here. An internal router is one that has all of its interfaces that are inside of an area. It doesn't have any that are shared between two areas like these two guys down here. Now, the routers that are in this area, and this area are, also internal routers, but we don't know about those, and they're just in some cloud, so we're not going to worry about those. So R2 is an internal router because it has all of its interfaces inside of an area, whereas the other two don't. Next, which routers are backbone routers? Now, any router that has its interface, at least even one interface, that's inside of area 0, because area 0 is our backbone area, would be considered a backbone router. So that's what that is. R1, 2, and 3. Which routers are area border routers? Now, an area border router is any router that has its interfaces in 2 or more areas. So R1 would be an area border router, as would R3, because they share the area 0 and area 1, area 0, area 2. Next, which routers are autonomous system routers? Now, an autonomous system router is one that is sitting at the edge of an area, for instance, maybe something over here, and then from that it goes off to another external network, maybe the internet or something, your ISP, whatever. But in this network, it's not configured to do that, so we don't have to worry about it. So none of the routers listed are autonomous system routers. Let's see, which routers are generating type 1 LSAs? They're all doing that. LSA 1s are packet 1s for link state advertisements, just share directly connected routes with other routers. So all of them are directly connected to something, and they're just going to share those information back and forth. Which routers are generating type 2 LSAs? Well, you can pull this up here, and I'll show you how to do this here. Let's go back to end, show IP OSPF neighbor, I believe it is. Okay, you'll see that on R1, there is a designated router. There's 2 of them that are connected to R1. There's one for this network, and there's one for the other network. So anytime an LSA type 2 is shared, that's going to be from the designated router or the backup designated router. So that's what shares those. Now, they are being shared, but they're from this cloud, so they're kind of hiding from us, hiding from our view. But you can, what I did is I gave the the network or the router IDs. So there's 4, 5, 6, 7, and 9 that are being shared. Let's see, what routers are generating type 3 LSAs? Now, those are routers that have interfaces in two separate areas, and then are going to share those to other routers inside other areas. So, for instance, R1 has got its interfaces in two separate areas, so it's going to share those link state 3 advertisements over to R3 and R2 about other areas. So both R1 and R3 are doing this because they both have interfaces in other areas than R2, and R3 isn't part of area 1, so it's going to get some of those as well. And vice versa. You know, R3 will share about R2 to R1, so it knows about that. Now, which routes are generating type 4 and type 5 link state advertisements? Now, those are things that come from autonomous system border routers. So those two packets are not going to be shared. Those two types of packets are not going to be shared by anyone because none of them are autonomous system routers or border routers. So what those two packets do basically is say, hey, there's an external network to OSPF this way. So that could be EIGRP, that could be a RIP network, that could be a number of things. But most typically it's going to be your outside internet ISP, but not always. How many inter-area routes does each router have? Well, R1 and R3 have 2, R2 has 4. How do we know this? Let's see, I route OSPF. So the inter-area routes are going to be signified by the IA next to the O. So the O tells us, of course, that it's an OSPF learned route. The IA says inter area. So it's coming from some other area other than the one I'm connected to. So that would be, let's see, it's a 192.168.1. So that's going to be that guy right there. 192.168.2. That's going to be that network over. So these two networks basically from R3, because R1 is not privy to R2's network, so it's going to have to be shared about that by a router's interfaces that are outside of that area. So it says, oh, okay, those are outside, external to my areas, but at least I know about them. We can do the same thing in R2. And you'll notice that we've got every one of its routes that have been learned through OSPF, and they're not directly connected, are inter-area learned routes through OSPF. We've got 2 over here, 2 over here, because R2 isn't connected to either one of those areas. It's an it's an inside router. Lastly, R3, and of course you kind of see where we're going with this. It's going to have to be learned about those two. So again, we've got 2 routes over here that it doesn't know about normally, being that it's not connected to that area. So there you go. Lastly, why would there usually be an ASBR, an autonomous system border router, in this type of network? Well, basically I explained that already. It would hook you up to, or it would tell you that there is an exit out of OSPF controlled network and into maybe an EIGRP network, or an ISIS network, or something of that nature. Basically, most likely would be an exit route to the internet, though. So there you go. That is this packet tracer. I think went a little long, but I appreciate you guys checking it out. If you have any questions, please put them in the comment section below. Please like, share, subscribe, all that happy garbage. And if you ever need any help, I am just a comment away. Talk to you guys later. Peace.